Hi everyone, I'm really excited to be here with you today. In this session, we are going to explore one of the most important and useful topics in modern C Sharp, asynchronous programming. In today's world, people expect apps to be fast, smooth, and responsive, and nobody likes it when an app freezes or becomes unresponsive. Async programming helps us write code that doesn't get stuck when doing something long, like downloading data, waiting for a response, or reading a big file. Okay, before we dive in, here is a quick look at what we will explore today. We will start by understanding why async matters, and then we will look at how it works with async and await. And we will also talk about parallelism, how to avoid common mistakes like deadlocks, and wrap up with best practices. By the end, I hope async programming will feel much more friendly to you. Okay, imagine you're at a coffee shop, you order a latte, and you don't stand in front of the barista and wait while they make it. You got sit down, and the barista can help other customers in the meantime. That's exactly how asynchronous programming works. When your code needs to do something slow, like calling a web API, it doesn't just wait and freeze everything. It lets the rest of the app keep going, and without async, the whole app would stand in line for every slow task. Okay, let's compare two styles. The first one is synchronous, that one task runs at a time and it finishes, then the next one starts. As simple, but it can block the app. About the second one, tasks can start and run in the background. The app can do other things while waiting. Think about cooking. If you cook rice, wait for it to finish, then start frying eggs. That's synchronous. But if you start the rice, then fry the eggs while it cooks, that's asynchronous and it's more efficient. In C Sharp, we use two special keywords, async and await. Async marks a method that can run asynchronously, and await tells the program, pause here but don't freeze the app, and wait until this task finishes. And it's like saying, hey, go do this, and when you're done, come back here. In C Sharp, asynchronous methods usually return a task, and a task represents a work that's running or will run in the future. And you can think of a task like a promise, and it's like I'm working on it, I will let you know when I'm done. And this method promises to give you an integer later. So instead of waiting for something to finish now, we wait for the task to complete. Let's say you are cooking pasta and baking cake. You don't wait for the pasta to boil and doing nothing. You start the pasta, then while it's boiling, you prepare the cake. That's how async works. Your app can start something, then move on and check back later. This is efficient and makes your app feel fast and alive, but don't use async for things that are already fast. For example, like basic math or string manipulation. You will see both async void and async task. And what's the difference? Async void is mostly used for event handlers like button clicks, and async task is used for everything else. And the question is why? Because a task can be awaited and tracked and error handled. So avoid using async void unless you have to. Let's talk about parallel programming. Parallel programming is all about doing multiple things at the same time, especially useful when you have CPU-heavy operations like image processing, complex calculation, or any task that can be broken into smaller independent pieces. In C# we can use parallel.for or parallel.invoke to run pieces of code on different threads. For example, imagine you have to process 1,000 images. Instead of processing them one by one, you can use parallel programming to handle many images at once. And this can greatly improve performance. But remember, parallel programming creates multiple threads, so you need to be careful when accessing shared resources. Okay, async methods can throw exceptions just like normal methods. But if you don't await the task, you won't catch the error. So always use try catch around await calls. Here is a common mistake. If you call an async method but forget to await it and it throws an exception. The exception might crash your app later or be completely ignored. So to avoid this, wrap your await calls in try-catch blocks, just like this example, and this makes your async code more reliable and easier to debug. Okay, this slide is a very important comparison. People often think that async await and parallel programming are the same, but they solve different problems. Async await is perfect for IO-bound tasks, and these are tasks where your code spends time waiting for something like a web request or file access, and it doesn't use extra threads, it just waits smarter. On the other hand, parallel programming is for CPU-bound work and tasks that need a lot of processing. It uses multiple threads to do heavy work at the same time. And here is an analogy. Async is like ordering food at a restaurant and doing other things while waiting. And parallel is like having multiple chefs cooking different dishes at once. So you can even combine both, run multiple async tasks in parallel using task when all method, but understanding the difference is a key. So this part of the talk is one of the most important ones because a lot of people, even experienced developers, get confused between async and parallel programming. They sound similar at first. I mean, both of them are used to make applications faster and more responsive, but they actually work very differently and are used in different situations. Here is a simple way to think about it. Async programming is about waiting and parallel programming is about working. With async, we are saying, hey, this task will take time, like calling an API or reading a file. So instead of just sitting here and do nothing, I will go do something else while I wait. It's like ordering a pizza. You place the order, and instead of standing by the door, you go clean your room or watch TV or even continue working. And you are not cooking the pizza, you are waiting for it to arrive, but you are not wasting that waiting time. On the other hand, parallel programming is used when you actually need to do multiple things at the same time. Let's say you want to bake 3 pizzas and you have 3 ovens. If you only use one oven at a time, it will take a long time. Sorry. But if you put a pizza in each oven and let them all cook at once, that's parallel work. And in programming, parallelism usually means that you are doing CPU-bound work and something that uses a lot of processing power, like heavy calculations or image processing or looping through millions of records. And async in contrast is best when you are doing IO bound work. That means tasks where your program spends most of the time just waiting for data from the internet or from a file or database. Instead of blocking thread and freezing the app while waiting, async lets the program continue doing other things and only can come back when the result is ready. And here is the cool thing that when you write async code in C#, you don't create more threads. It's not heavier, it's actually more efficient because it lets the same thread serve many users or do many things over time without wasting resources. But the question is, can we use both together? And the answer is yes. We can run multiple async tasks in parallel. For example, if you want to download 3 files from the internet at the same time, you can use when all method and await all 3 together. But again, remember you are still doing IO bound work and you are waiting for 3 things at once and not doing heavy calculation. And about this part. And so here is what you should take away from this. If your code is waiting, like reading, downloading, connecting, and something else, use async await. But if your code is working hard, like calculating or another things, use parallelism and multiple threads. They both improve performance, but in completely different ways. And when you mix them up, for example, using parallel threads for something that's just waiting, you actually make things slower, not faster. Because you are using extra threads for no reason. So always think first, is my code waiting or working? And that simple question helps you choose the right tool. And understanding this difference will help you write smarter and faster apps that feel responsive, don't freeze, and also scale out well when more users come in. Okay, let's talk about next slide. When multiple threads try to access and modify the same data at the same time, bad things can happen. and this is called the race condition. To prevent that, we use the lock keyword in C sharp. Imagine bathroom with one key. If one person is inside, others have to wait, and that's exactly what lock does. It allows only one thread to enter the critical section at a time. This is very important in parallel programming, but sometimes also useful when multiple async operations work with shared data. Here is a real life use case where async programming shines, downloading a file from the internet. If you do this with synchronous code, your app will freeze until the download is complete. That's a bad experience for users, but if you use await with HTTP client, your app stays responsive and you can download files in the background while the UI keeps working. And here is a simple line. And this tells your app start download, and when it's done, give me the result, but don't block the user interface while waiting. Okay, sorry, 1 minute. Okay, we can work with asynchronous data streams using await for each. Let's say you are receiving data from a remote server in chunks or reading a huge file line by line. Instead of loading everything into memory, you process each item as it comes. And this is called an asynchronous stream. It's like watching a YouTube video, and the entire video isn't downloaded before you start watching. It streams bit by bit, and this is efficient and modern, and you get better performance and use less memory. Let's talk about a scary word, deadlocks. A deadlock happens when your code is waiting for something that never happens, so it's stuck forever. This often happens when you mix async code with result or wait method. This forces the task to block the thread, which can prevent the continuation from running. To avoid this, always use await properly. Also use configure await when you don't need to return to the original context, because this makes your code more efficient and reduces the chance of deadlocks. Sometimes you want to stop an operation in the middle. Maybe the user closes the app or cancels an action. Async methods support this using cancellation token. You pass a token to your method, and inside your method, you check if cancellation was requested. And if yes, you can stop early. And it's like giving someone a walkie-talkie and say, if I say stop, you stop immediately. And this helps you build apps that are smart and responsive to the user. Okay, that was my presentation. Thank you so much for your time and attention. I hope this session helped you understand how async programming works in C# and how powerful it can be when done right. So have a nice day and bye.